part 3, we have an answer to part 2, which was 1.05083. Yeah, and that's a root to this equation, because this equation can be rearranged to this iterative function. So a root for this is 1.05083. And now it's brought in this new function here that kind of looks a little bit like the first one, but it's changed. There's a sec squared instead of a tan squared, and there's a 2x here instead of the x. And how is this a deduce, like a hence find? Well, if we start thinking about how tan squared and sec squared are related, we should hopefully know that tan squared plus 1 is equal to sec squared. And therefore a sec squared x a tan squared x can be written as sec squared x take away 1. So I'm going to take this equation, because we know a root to this equation, and I'm going to swap this tan squared x for sec squared x take 1. So taking this tan squared x and changing it to sec squared x take 1. And so a root to this equation here, this new equation here, is also 1.05083, because they're the exact same thing, they're just written differently. And now you can see it looks a little bit more similar. We've got the sec squared and we've got the 3 as well. But what we have different here to here is that the x has been swapped for a 2x. So if a solution to this is that x is 1 plus 1.05083. For this equation, well, what will a root be if we've got this slightly different equation, where we've got a 2x? Well, all we would do is say, well, for this, we know that 2x is equal to 1.05083. And therefore, if we're trying to solve it, if we're trying to find out what x is, we're just going to halve it. And if we halve it, we get 0.525441. I've just halved that full answer that I had on the previous part 2 by 2.